4.8. Okay, find the Laplace transforms of the following signals using only a Laplace transform table and the time shifting property. So I copied the transform table here so we can refer to that whenever we need, and we should use only the shifting property. But what is the shifting property? Well, we can write the shifting property for a signal xt like this. So assume for a signal xt, the Laplace transform is x of s. Okay, so if I shift the signal xt here by t0, then I still can find the Laplace transform of the new signal or the shifted signal using the signal we have here, and the Laplace transform for this would be x of s e to the power of minus s t0. This is the shifting property. So let's see how can we solve these three problems. Well, I think we have enough time, so we can solve all three here, or we can solve either just one of these and then start from the beginning. Okay, so let's see what happens. The function here is xt. The signal here is xt, which is ut minus u of t minus 1. Okay, so if I want to find the Laplace transform of xt that equals to the Laplace transform of u of t minus u of t minus 1. And because of the linearity, the linear property of Laplace transform, I can write this like Laplace transform of ut minus Laplace transform of u of t minus 1. Okay, so we already solved this and we found that what is the Laplace transform for this. And even if I check the table here, you see when x equals u of t, its Laplace transform is 1 over s. All right, so that means we have 1 over s for the Laplace transform of u of t minus, and now we have u of t minus 1. So I know Laplace transform of ut is 1 over s. Okay, so check this, and that means u of t minus 1, the Laplace transform for this one is x of s, which is 1 over s, times e to the power of minus s times t0, which is s times 1. So let me write it in the correct order. So s times 1, which is e to the power of minus s over s. Okay, e to the power of minus s over s. So I can write it equal to 1 over s times 1 minus e to the power of minus s. So this is the Laplace transform of this signal here. Okay, once again, well, we want to find the Laplace transform for this signal x of t, but x of t has two parts, ut minus u of t minus 1. Okay, so the Laplace transform of xt equals Laplace transform of ut minus 1. Okay, and because of the linear property of Laplace transform, I can write this Laplace transform, I can decompose that to Laplace transform of the first item plus Laplace transform of the second item, and the second item is minus u of t minus 1. I can take out this minus, so it becomes Laplace transform of ut minus Laplace transform of u of t minus 1. Okay, I want to see what is the Laplace transform for ut. It's enough to check the table here if we can't calculate that directly. So this table of Laplace transform says that if the signal is ut, its Laplace transform is 1 over s. Okay, so I replace that, the Laplace of ut is 1 over s minus, and we have Laplace transform of a shifted version of ut, shifted by 1 unit of time. So I need to calculate to find the Laplace transform for this one. Okay, this is the shifting property of Laplace transform, and that says if Laplace transform of xt is x of s, then the Laplace transform of the shifted version of x equals x of s times e to the power of minus s times the shift value. So how much is the shift value? So if I do that for this Laplace transform of u of t minus 1, well, we know the Laplace transform of u of t is 1 over s, and then we should multiply that to e to the power of minus s times t0, and t0 here is 1. So I replace t0 by 1, we would have e to the power of minus s. Okay, I put it here. Then I can write that, simplify that, and write it in this form.